Hi and Assalamualaikum, my name is Iman Batrisha and I'm from AS 25568. So today I'll be presenting my thesis titled Properties of Polymeric Bio-Composite Pbat Reinforced with Kenaf Bast Fibre. Now before we get into the details, a little bit of an overview of my presentation. Firstly would be the introduction, then the problem statement, and then the objective, and then the significance of study, methodology, result and discussion, and lastly conclusions and recommendations. Now, let's get to know Pbat and Kenaf. Before that, we have to know that Pbat is a biodegradable polymer. Biodegradable polymers are natural plastic that can be broken down by microorganisms including fungi, algae, and bacteria. Polylactic acid, PLA, polyhydroxyl alkalinate, PHA, and starch have little impact on the environment's carbon footprint. Pbat, on the other hand, is a biodegradable polymer that has become researchers' preferred choice to reduce global-wide pollution. Now, Kenaf plant, or known as hibiscus cannabis, is an excellent polymer matrix filler. It is a native to Asia and Africa and today is a global industrial crop. It can grow about 4 to 5 months after its seeds are planted and making it ideal for large-scale industrial production. The plant can reach over 3 meters tall and 3 to 5 millimeters wide. One of the various elements of the Kenaf plant that can be removed is the tall stem, which produces the long fiber. And it is reported that the exterior and inner layers of the Kenaf stem are made of bast and core fibers. Now, what is the problem that needs to be solved here? At the beginning of processing, fibers are just visually categorized. The first waste is produced when the fibers do not pass the screening test, and according to Todor and other authors, 15% of production waste comes from fiber processing. And due to this large volume of waste, composite can actually be used in large civil engineering projects. A study from Fajrin and other authors stated that the fractography from SEM was used to find the best fiber orientation for mechanical properties. Therefore, this study will focus on Kenaf fiber reinforced with polybutylene adipate core terephthalate or Pbat. The objective of this study, first one, is to evaluate the mechanical and physical properties of Kenaf fiber Pbat Bio-Composite. The second one is to investigate the compatibility between Kenaf fiber with Pbat, and the third one is to study the biodegradation behavior of Kenaf fiber and Pbat biocomposite under the natural soil with no agrochemicals added. Moving on to the significance of this study is that this study will examine the physical and chemical properties of Kenaf fiber with polybutylene adipate coterephthalate or Pbat, which is a biodegradable material that could safeguard terrestrial or marine ecosystems. And throughout this chemical and physical test, this study will show Kenaf fiber and Pbat's compatibility. Finally, this study will determine the biodegradability of reinforced Kenaf fiber with Pbat, which will benefit the country and consumers by reducing environmental concerns. Let's understand the methods to this study. Firstly is obtaining 2.16 kg of Pbat biocomposite from a local company in Pahang, and then separating Kenaf bast from its core before grinding it to a finer size, where throughout the study only 60 matched sizes were used. And after the sample was obtained, a series of chemical analyses were done, such as determining the moisture content, hot and cold water solubility, ash content, lignin, hollow cellulose, alpha cellulose, and 1% of NaOH solubility and alcohol tolerance solubility. Before testing of biocomposite, fabrication of biocomposite were done where mixing the samples in a Rio mixer for 13 minutes to allow efficient dispersion, where the neat matrix was melted first, then sawdust was added. Then, moving forward to casting and curing that produced 3 different molds of 3 different percentages of Kenaf Pbat biocomposite, which consists of 10%, 20%, and 30% of Kenaf fiber. Now, for testing its mechanical properties, we had to test its tensile strength and its dimensional stability, where the biocomposite were submerged in deionized water for a week to observe its water absorption and thickness swelling. Moving on, to test its biodegradability, we conducted a soil burial test at the Arboretum of UiTM Jengke, where we recorded the first month and second month of its weight loss. Lastly, we observed the microstructure of the biocomposite under SEM image. Now, for results and discussion, the chemical analysis of the experiment on Kenaf's bust showed that it has 6.2% of moisture content, 1.15% of water solubility in hot water, and 2.16% in cold water. Then 28.2% of solubility in 1% of sodium hydroxide and 2.4% of ash content. And then Kenaf Bast has 2.11% of solubility in alcohol toluene, 10.55% of lignin content, 75.43% of hollow cellulose, and 66.47% of alpha cellulose. Kenaf's Bast has low lignin content, high hollow cellulose and alpha cellulose, which gives it strength and makes it a good material for paper pulp. However, there is room for improvement in this experiment. Next is the result for physical properties is the density of Pbat reinforced with Kenaf fiber was studied at 3 different percentages, which is 10%, 20% and 30%. The results showed that KF30 had the highest density, which resulted in lower porosity and better mechanical properties compared to KF10 and KF20. Determining the density of a composite helps to determine other properties such as chemical and physical properties, tensile strength, thickness, swelling and water absorption. Now, for tensile strength, among different Kenaf Bast fiber reinforced biocomposites, the one with KF20 had the highest tensile strength. Tensile strength measures a material's resistance to stretching and the force required to cause it. Adding Kenaf fibers to a matrix makes it stronger by filling in the spaces between the fibers and reducing deformation. The matrix also transfers stress effectively to the Kenaf fibers. For dimensional stability, KF30 has the highest water absorption among composites due to its high Kenaf fiber content, which has hygroscopic properties. A study showed that the more Kenaf fiber in the composite, the more moisture it can absorb. Another research was found a connection between water absorption and swelling with increased fiber loading, so having more fiber helps maintain dimensional stability. In addition to that, it is found that KF30 has the highest swelling compared to other composite. There is no link between density and swelling rate. But KF30's high swelling is probably due to agglomeration during mixing, which allows water to enter voids and fill gaps despite its high density. For the biodegradable analysis, the study found that KF10 held up well in the first and second month, meaning it degrades faster than other biocomposites. However, even with good water retention, the other composites still degraded over time, only at a slower pace. The SEM results showed that Pbat only coated the Kenaf fiber as shown in the reticle of KF10 image and made the biopolymer stronger. When force was applied, we can see that the bonding process occurred and resulted in a cut-off of the bonding broke as circled in the image under KF20. The optimal percentage of Kenaf fiber composite for production was found to be 20% or KF20 because it had the smoothest surface, likely due to better compatibility and integration between Kenaf fiber and Pbat. In conclusion, these studies, various tests were conducted on a biocomposite made of Kenaf Bast fiber and Pbat. The results showed that the biocomposite has high potential to be an environmentally friendly product, thanks to Pbat's biodegradability and the reinforcing effect of Kenaf fiber. The best results were found with a specific ratio of Kenaf fiber, which is the KF20, had the highest tensile strength and lowest dimensional stability compared to other biocomposites. Additionally, KF20 resulted in the most ideal composite according to SEM images, and Kenaf Bast fibers are a promising material for use in environmental friendly biocomposite. However, more research is needed to determine the best way to utilize Kenaf as a replacement for plastic. Now, to wrap up my presentation, a few recommendations to improve the future research on Pbat biocomposite reinforced with Kenaf fiber. The potential areas of investigation includes increasing fiber loading for improved mechanical properties, fiber treatment to enhance bonding, altering the matrix to improve properties, and comparing properties with other biocomposites. That's all from me. Thank you.